Hello and welcome all students. How are you? Students, in the previous session of thermodynamics, we discussed about the laws, first law, second law, third law, and also about the numerical of these laws. In today's session, we will start the new segment of thermodynamics, that is chemical energetics. In the chemical energetics, students, basically we study about the amount of energy which is involved in the chemical reaction. So what kind of energy and what is the amount of energy which is involved in the chemical reaction? What are the energetical aspect of the chemical reaction? That we will discuss in today's session. So students, in this unit thermodynamics, today I will tell you about the new part of thermodynamics. In this chapter thermodynamics, we studied about the first law of thermodynamics, and then we studied about the second law and third law of thermodynamics. Now it is time to study about the chemical energetics. So what is chemical energetics? See, it is the branch of chemistry that deals with amount of heat involved in different chemical reactions. See, around us different chemical reactions take place every day. So in the different chemical reactions, what amount of energy is involved, that exactly we study in chemical energetics. See, in the chemical energetics, we not only study the amount of energy, we also study the different kind of energies which are being involved in the reactions. So before we start chemical energetics, it is important for us to understand few terms that we would use in the chemical energetics. First, I shall tell you about the thermochemical equation. See, what is the thermochemical equation? Now what we have to do, we have to consider a reaction. Suppose we considered this reaction, which is combustion of alcohol. This equation must be balanced. This is condition number 1. Let me tell you, there are some certain conditions, and if these conditions are fulfilled, there are some certain conditions, students, and if these conditions are fulfilled, we call reaction as a thermochemical equation. So if any chemical reaction fulfill some certain conditions, it is called as thermochemical equation. So the chemical reaction which involve energy change and it is balanced, for being called as the thermochemical equation, this equation must be balanced. It must be balanced. Now another condition in the thermochemical equation, see, in this combustion of alcohol, it is written C2H5OH liquid, 3O2 gas, 2CO2 gas, 3H2O liquid. So what we are doing here is we are mentioning physical state of reactant and products as well. So if the physical state of all the reactants and the products are mentioned in the chemical reaction, it is called as thermochemical equation. This is condition number 2. Another condition, see, in any chemical reaction, as far as the energy is concerned, either energy will be absorbed or energy will be released. See, if delta H value is positive, it means reaction is endothermic, energy is absorbed. But if delta H value is negative, energy will be released and it is exothermic. Energy will be released. This energy will be released. Now C2H5OH, when reacts with the oxygen, give carbon dioxide and water, delta H is 1430 kilojoule per mole. Now if this heat is represented in the given chemical equation, then it is called as thermochemical equation. This is condition number 3. So if you want any reaction to be called as thermochemical equation, it should fulfill 3 conditions as of now. Number 1, it should be balanced. Number 2, physical states should be mentioned of all reactant and product within the reaction. And number 3, whatever the amount of energy, whether it is absorbed or released, it should be represented in the equation. If these conditions are fulfilled, then this is called as thermochemical equation. In any chemical equation, students, suppose you see any equation is given in the question, and if reaction conditions are not mentioned, that what is the temperature, it is not mentioned what is the pressure, then by default we consider these conditions as 298 Kelvin and 1 atm. Pressure should be 1 atm and temperature should be 298 Kelvin if nothing is given. And if something is given, then definitely you have to consider whatever given. Now you see another point of thermochemical equation. If I consider this equation, what it was, it is the combustion of ethanol, where ethanol combines with the oxygen, produce CO2 and water. Heat of this reaction is minus 1430, means 1430 kilojoule energy released per mole of this reaction. Now if I reverse the direction of reaction, then what happens? If I believe that CO2 and water reacts and give methanol and oxygen, then the amount of heat will be exactly same numerically, just change in sign. Instead of negative, it will be positive now. So whatever the delta H of the forward reaction is equal to the negative of the delta H of the reverse reaction. This was also called as Laplace law, as this formulation was given by Laplace. Now, according to the concepts of the chemical energetics, enthalpy of an element in the standard state is considered to be 0. Please remember, it is not actually 0. It is considered to be 0. So whenever you have any element in standard state, standard states means pressure should be 1 atm, temperature should be 273 Kelvin, its enthalpy will be considered as 0. So standard enthalpy is 0 for any element, not for all. Alright. Now in this unit, chemical energetics, we shall further discuss Hess law of constant heat summation. It is Hess law for the constant heat summation. What is the Hess law of constant heat summation? What do we mean by the Hess law of constant heat summation? See, the Hess law of constant heat summation, according to this law, total enthalpy change of a reaction is same whether the reaction take place in the single step or in the several step. Means if a chemical reaction take place in more than one step, then whatever the amount of heat which was involved in the reaction will remain same. It will remain same. It will not be changed. See, say for example, if we start reaction with the A and we go towards B, the heat involved is delta H. This is second path. In the first path, we convert A into C, then C into D, and then finally D into B. In this path, there are 3 steps involved, and the reactions which are involved, delta H1, 2 and 3. And here in the second step, Second path where we directly converts A into B, heat involved is delta HR. So according to the Hess, total energy which was involved in the first step, which is delta H1 plus 2 plus 3, will be equal to the total heat involved in the second step. This is called as Hess law. Students, please go through it once. What are the different applications of Hess law? Where do we apply this Hess law? In any thermochemical equation. If any thermochemical equation added or subtracted or multiplied with each other or divided by any number, if you add the reaction with the another reaction, if you subtract the reaction from the another equation, if you multiply the reaction with any number, with any coefficient, or you divide the equation by any number or by any coefficient, then we apply Hess law. If it is not possible to determine experimental value of the enthalpy of reaction, it can be calculated by Hess law theoretically. See how interesting is this? Chemical reactions are practical aspect. They take place practically and their energies are also calculated practically. But if because of any condition somehow you are not able to calculate the value of energy experimentally, then you would be able to calculate it by Hess law on paper. So calculation of the heat of reaction which do not take place directly, some reactions which do not take place directly, we can calculate their heat even though they are not happening in reality, but yes, we can calculate their heat by using Hess law. How this would be possible? Also, we can calculate the heat of extremely slow reaction which take place with a very slow speed. We can calculate the heat of extremely fast reaction which take place in some millisecond or microsecond or nanosecond. Hess law also helps us to calculate the heat of ionization of weak acid and also weak base. You know, weak acid for which alpha is less than 100%, and for weak base also degree of dissociation alpha is less than 100%. So we can calculate heat of the ionization of weak acid and weak bases as well with the help of Hess law. It is used to calculate the calorific value of the fuel. You must be thinking, sir, what is calorific value? Do you know what is calorific value? Calorific value is heat obtained by combustion of 1 gram fuel. It is not about 1 mole fuel. When we calculate the heat of combustion of 1 mole fuel, it is called as heat of combustion. But when it is calculated for 1 gram, then it is called as calorific value. So yes, I can also say this. Calorific value is equals to heat of combustion divided by molar mass. If we divide heat of combustion by molar mass, you will get calorific value. Now, one question is given in order to make you understand Hess law in much better way. Calculate the heat of the reaction. Which reaction? CO2 plus H2 gives CO plus H2O. Heat of this reaction has to be calculated. Students, heat of this reaction has to be calculated, and heat of this reaction is given, and heat of this reaction is given, and heat of this reaction is given. First reaction is carbon plus half O2 gives CO. Second is carbon plus O2 gives CO2. third one is H2 plus half O2 gives H2O. And all three values of the respective reaction, value of the heat, enthalpy for these respective reaction is already given. Now what you have to do, you have to calculate this question or solve this question in such a way so that by using these three equations you would be able to get this equation which is being required. How you would do that? First, you see what we need is CO2. 1 mole of CO2. In these three reactions, CO2 is here. Yes, of course it is 1 mole. What we need is 1 mole, but it is on the another side. So what we will do is we will reverse this equation. As the moment you will reverse this reaction, its heat will also be reversed. See, here heat is minus 394, here it is plus 394. What else you need? You need one hydrogen on left hand side. Fortunately, it is already on left hand side. Fortunately, it is already on left hand side. So you don't have to convert side of the hydrogen. So in this case, you just simply add the equation third in the equation 2. When you will add the equation third in equation 2, you will get hydrogen here. Now what you need is carbon monoxide and water. Carbon monoxide is also here. So you just have to add equation 1. By adding these three equations, we will do the same thing along with their heats. In the same pattern where their heats are added and subtracted, same like their reactions are added or subtracted. And after calculation of this, the final value comes plus 41.4 kilojoule. So this will be the heat of this reaction. All right, these are the application of Hess law. Now further in this unit, I would like to tell you something about the standard enthalpy of formation and thermochemical equation. Thermochemical equation we already studied. Now it is time to study about the standard enthalpy of formation. See, we can form any substance by n number of methods. It is not like that we have only one kind of method by which we can form the any product reaction can be proceed. But in any reaction, my dear students, in any reaction, standard enthalpy change for the formation of 1 mole of the compound from its element in their stable state. What does it mean? Say for example, you have to form water, H2O. So water, which is H2O, it is made up of two elements. Number one is hydrogen and the another element is oxygen. First element is hydrogen and another element is oxygen. In these two elements, hydrogen and oxygen, hydrogen could be found in nature as nascent hydrogen and also as hydrogen gas. Similarly, this oxygen could be found as nascent oxygen or molecular oxygen or ozone. Out of these two forms of hydrogen, the more stable form is H2. And out of these three forms of oxygen, nascent oxygen, molecular oxygen and ozone, out of these three, the most stable form of oxygen is O2. When you will form water with the help of most stable form of its component elements, then heat released is called as enthalpy of formation. And if this reaction take place Under the standard states, this will be called as standard enthalpy of formation. Alright, please note down. Now another is heat of combustion. What do you understand by heat of combustion? Yes, it is heat released. It is heat released when 1 mole compound is completely burned in presence of oxygen. Now the point is, what do you mean by complete combustion? What is complete combustion? See, I burned carbon in presence of oxygen and I formed carbon monoxide. At the same time, I also burned carbon in presence of oxygen in a different way and formed carbon dioxide. Out of these two equations, one is complete combustion and the another one is partial combustion. Carbon belongs to group 4th or 14th as per the new nomenclature. And what is the range of oxidation number? Range of oxidation number of carbon. We studied that in the previous units. Range of the oxidation number of carbon will be +4 to -4. This is the range of oxidation number of carbon. This is the range of the oxidation number of carbon from +4 to -4. Till the moment carbon will not convert into the +4, which is highest oxidation number of carbon, it will not be considered as complete combustion. So carbon, which is in 0 oxidation number state here it goes in +2. So this is not complete combustion. Students, it is partial combustion. And here, when carbon goes from oxidation number 0 to +4, which is highest possible oxidation number of carbon, it is called as complete combustion. So when combustion is complete, this is called as heat of combustion, ΔHc, whereas this will not called as heat of combustion as it is partial combustion. Alright, so students, this was about the combustion and heat of formation. Remaining heats we shall discuss in the coming class. I hope you liked today's session and it was informative for you. Please keep coming and keep studying. Good luck.